All right, let's take this opportunity right now to do a brief, as brief as I can make it, review of fossils in geologic time. A fossil is a good place to start. Fossils are going to be how we organize geologic time, so we'll do fossils first. Fossil is going to be preserved evidence of past life. This preserved evidence of past life can look different depending on what your fossil is. Um, you can have a track or a trail, you can have a burrow, some evidence of an animal feeding or a creature feeding in a place. Uh, and those sorts of remnants or relics, those are going to be trace fossils. Um, that's basically all that we need to know about trace fossils. There's a bunch of different kinds. The fossils are not going to be fossils of any particular organism, but they're going to be how that organism existed in that place. The part of fossils that we think about mostly are going to be the preserved parts of organisms. These are going to be called some sort of a body fossil. These preserved parts of organisms are going to be hard parts primarily. These hard parts could be bone, shell, tooth material if you're talking about an animal. For plants, you're going to have the larger plant tissues like stem materials will be the primary preserved parts of those organisms. In some specific environments, you can also have like leaf impressions and things like that preserved as fossils. But mostly we're going to be talking about those larger hard parts like stem material. These preserved parts can look like maybe original material, like this spider that was trapped in amber. Amber is a hardened tree sap that turns into a rock. You can have an imprint or a filling. Those would all be ways that you could preserve body parts of organisms. You can have it turned to stone. You could have an organic residue left behind. These different types of fossilization are going to have specific names associated with them. If you have preserved original material inside of amber or inside of a rock where the shell just didn't turn into anything else, or in ice or in any other way, um, that original material is called a preserved fossil. So you actually have your preserved original organism part left behind. The imprint is going to be a mold. The filling is going to be the cast. Molds and casts are really frequently confused with each other. So the mold is going to be the thing that is filled in by the cast. So you can have casts and molds together. The cast fills the mold. Turned to stone is petrification. Turned to stone can also be called permineralization. Um, but petrification will work for our purposes. The organic residue left behind is also called a carbonized fossil. Now, some fossils live for a very short period of time in lots and lots of places. These fossils are useful for telling time, and these fossils are going to be called an index fossil. So index fossils are organisms that live for a very short period of time in lots and lots of places. They are going to be easy to identify. They are going to fossilize well. They will be common, and they are used to estimate time. Index fossils are best if they're easy to identify. If you're trying to identify a fossil and use it as an index fossil, it can be really a frustrating experience. So you want them to be easy to look at. And that's the end of fossils. That was one slide that covered all of fossils. Now we're going to make one slide that covers all of geologic time. This geologic time, this is how Earth scientists organize the history of the Earth. You're going to it's organized mostly off of index fossils, really. And then we'll use absolute age dating to get those numbers. We don't have to worry about that right now. That's what the next video is going to be about. Geologic time is broken into pieces, we've got big pieces, middle pieces, and small pieces. Our eons are our big pieces. Those are the biggest portions of geologic time. We have two of them. We have the Precambrian eon and we have the Phanerozoic eon. You may not have heard of the Phanerozoic eon, and there's a very good reason for that. The Phanerozoic eon is broken into 3 eras. Eras are going to be portions of an eon. Precambrian eon is also broken into portions. Those would be the Hadean, the Archean, and the Proterozoic. But for our purposes, we don't need to worry about any of that. We're just doing the introduction here. And so the Cenozoic, Mesozoic, and Paleozoic are our 3 Phanerozoic eons. Phanerozoic eon is not important to know, though. It's not important to know because this eon is always referenced by the 3 eras that it contains. Now, those 3 eras are going to be broken into smaller portions called periods. Periods are portions of an era. Now, there's lots and lots of different periods, and for our purposes, we're not going to need to know these for the same reason that you don't need to know the elements on the periodic table. If you ever need to use elements on the periodic table, you'll be given a periodic table. If you ever need to know the periods of the geologic time scale, you'll be given a geologic time scale. So those names will be given. I don't want you to spend time trying to memorize these things. That is not an effective use of your time for our current purposes. If you were to go further into the earth sciences, then eventually you would need to know these periods, but we aren't there, and so let's get rid of them. What we're left with then are the 3 eras and the first eon. These are the 4 parts that we do need to know about. So we have the Cenozoic, Mesozoic, and Paleozoic. I want to start with the prefixes there. Ceno means recent, Meso means middle, and Paleo means old. So you can have the old time, the middle time, and the recent time. Pre means before. And so the Precambrian will happen before the Paleozoic, Mesozoic, and Cenozoic. The Precambrian is the time before. It is the beginning time. The Precambrian is going to start with the formation of the Earth 4.54 billion years ago. And then everything else forms. Continents form, the atmosphere forms, eventually it cools down enough, the oceans form. During initial Earth formation, the moon is also forming, and the first life forms after water finally condenses to form oceans. And this is going to continue and develop for 4 billion years of time. So the Precambrian covers a lot of our geologic time. So here's our wheel of time. But it does have a beginning, and the beginning is the Precambrian eon. The Precambrian eon is all of this. So it's most of geologic time is Precambrian time, 8/9, to put it into a fraction that's easy to think about. So this is the majority of our geologic time scales right here. And that's all that we're going to really say about the Precambrian, because for our purposes, we want to be thinking about the Paleozoic, Mesozoic, and Cenozoic, because they have widespread fossils in them. First common fossils are going to start forming about 540 million years ago. That's when we finally have organisms developed to the point that they have hard parts. So that happens. We have our first invertebrates. Our invertebrates will be things like trilobites, brachiopods, and snails. Prior to this, in the Precambrian eon, you're going to be having your worms, sponges, and jellyfish. So worms are annelids. There's several different phylum of worms, really, but when we think of worms, we think of annelids. You're also going to have sponges, so that's porifera, and Jellyfish are Cnidaria. Cnidaria are going to develop into more complex organisms like coral. Coral are also Cnidaria, but they have a hard part around the outside of them instead of being all soft bodied. That hard part allows them to be fossilized. So we have our first common fossils. Our first common fossils are all invertebrates, meaning they lack a spinal cord. And then we have our first fish. So our first fish are going to look like sort of a worm, except it's going to contain a spinal cord of sorts, and it'll have mouth parts. The mouth parts are called conodonts, Conodont. So we have our very first fish, and they are going to develop over time. Throughout the Paleozoic, they get more complex. We get our bony fish and cartilaginous fish. Sharks don't change a heck of a lot from the Paleozoic to now. So they just sort of came out right the first time, you know. Fish are going to develop, speciate, radiate. Amphibians are going to begin to evolve from lobe-finned fish, and those amphibians are going to make it onto land. And they're like, yay, land, there's not a lot of organisms here for us to compete with. I think that we'll just take over the place. And they speciate and radiate out, and they develop into reptiles. Reptiles start to exist, and then a Pangea forms, and that's sort of a drag because all that continental shelf space around the edges of all the continents at the time sort of goes away, and we form one big continent with less shelf space. So our ecosystem decreases in size, and around the same time, a huge meteor hits Earth, causes a giant mass extinction. Something like 19 out of 20 species on Earth at the time go extinct. So this is the biggest mass extinction in Earth's history. The meteor that hits Earth causes a shock wave that goes through the Earth, forms melt. So much melt that we can still see the lava flow today. It's all over northern Russia. The lava flow is called the Siberian Traps. So the Siberian Traps form. 19 out of 20 species on Earth go extinct, and the Mesozoic era begins. Mesozoic era begins, the reptiles saying, hey, everything's dead, but we're not. So they become really successful. They get really big due to lack of competition, and those are the dinosaurs. And so begins the age of reptiles, which I did not put on the slide for some reason. The Mesozoic is called the age of reptiles. Mammals start to exist, but they're tiny and unimportant because the dinosaurs are having them for lunch if they start to have any sort of a foothold in an ecosystem. So like, hey, we're mammals, but we're scared. Birds start to exist. They're quite successful. They cause the pterosaurs to go extinct because birds start off cool. And everything's going along, everything's going great unless you're a mammal. And then a meteor hits Earth. Meteor hits Earth off the coast of Mexico, and all those big dinosaurs are dead. This causes a shock wave that goes through the Earth, causes a lava flow through northern India called the Deccan Traps. Deccan, I think. I really should have spell checked that before I just said it, but there we are. Mass extinction happens, the dinosaurs are dead, and we start the Cenozoic era. Notice that these eras begin and end with big mass extinction events. These two mass extinctions are both caused by meteors hitting the Earth. Now that's probably likely for our next one also. But the good news is the dinosaurs are dead, and so the mammals' oppressor is finally gone. So mammals are finally able to be successful on the Earth, and they get big, and they get diverse, and they get interesting. Birds are still successful, but we also get big versions of birds. So we get giant birds like the moa out in the Pacific Islands, and then we have in Madagascar the elephant bird. Those are both fun to look up. It's terrifyingly large. The elephant bird is scary. We've got big mammals. You've got like several 100-pound lemurs living in Madagascar. Obviously, elephants on every continent of the Earth. Then we have multiple glacial periods that happen. Lots of ice ages. We have ice ages throughout geologic time, but since these are so recent, they're still well preserved. These put a lot of pressure on the mammals, but there's also another creature that starts putting pressure on the big mammals. It's humans. As humanity begins to finally exist on the earth, then they hunt and kill the big mammals that are around because some of them are terrifying and others are food. Um, so they cause the extinction of many large animals and mammals and birds. They take over on 6 of their 7 continents, but humans have only been around for 4,540th of Earth history, so a trivial period of time. We find it a very important part of time since we are humans. But that's geologic time in a nutshell. And the end of our review. Please rewatch this as you need to.